thank you very much for the honour of being elected to fellowship. I really am delighted to accept the honour. So, I'm principally a neurosurgeon. I am good at tying knots, actually. So I keep operating. But I became a doctor in 1976 at the University of Melbourne. I became Professor of Surgery and Neurosurgery. I have been an academic all my professional life. I'm like all of you, I have a very inquisitive mind. I want to know why things the way they are and want to try and make things work better if they can be improved. And that's been my career, to try and stretch the limits of my field. I'm also, I've had a long defence career, and I suppose I've become very interested in what makes fine leaders. And I see a lot of bad leaders around, particularly in our political world, and I think I have something to offer there in helping young engineers and scientists develop leadership skills. Now, I've become particularly interested in medical engineering, and I think that's one of the reasons why I've been invited or elected to fellowship. I've been working with the engineers very closely for the last almost 6 years at Monash University to develop a bionic vision device, and that uses robotic vision algorithms, which I'll speak about in a minute. But having worked with them on a particular project, an interdisciplinary convergent science, if you like, project, I decided that we perhaps should broaden the horizon of medical engineering beyond what I was working on. So I spearheaded the development of a new institute at Monash University called the Monash Institute of Medical Engineering. The idea was to involve the entire medical faculty, the entire engineering faculty at Monash University, except for civil engineering. We haven't found a way that doctors can work with bridge builders, except metaphorically. But apart from that, all of engineering, the science faculty, the design and architecture faculty, the law faculty, business. In other words, it's an all-of-university virtual institute. Believe it or not, it only has 4 people in the headquarters, and I'm the director. The rest of it spreads its tentacles out to the entire university. It's a unique model, I think, and we've worked out a very effective way of bringing the engineers to work on unmet clinical need driven by the clinicians. And we particularly are involved with industry collaboration and with an end goal of commercialisation of what we're developing. In other words, helping people, but also helping build Australian industry and new jobs for the future with high technology manufacture. Now, this device that we're developing is almost ready for human trial. It's world-leading technology. I couldn't have done it on my own. It's a team effort, which particularly involves the electrical and computer systems engineers and the physiologists, but essentially the architecture of it is that there's a camera on the glasses frame, not much different from the camera in your mobile phone. That's not the secret of the device. The secret of the device is actually that and what's on the brain. That is a vision processing computer, a bit bigger than a mobile phone. It does exactly what we heard in the previous talks about autonomous vehicles, robotic vision that uses robotic vision algorithms for blind people to dissect out what in the environment is relevant to their brain to understand what's in front of them and behind them. It then connects wirelessly with Bluetooth type wireless interface with an antenna from the antenna on the back of the head to the electrode tiles in the brain. And these are the tiles that we've developed at Monash University. They're unique, they're ceramic, they have an integrated circuit chip in them which has 500,000 transistors which can individually control each of those electrodes. Wireless interface, it has to be waterproof, which is a big engineering challenge. It's being manufactured by a company in Melbourne called Minifab. I'm not doing an advertising exercise here, but I did want to emphasise that we've got 2 Australian companies working on this project. The other is Grey Innovation. And the reason for the success of this project is that it has involved industry from the very outset. And it's a model going forwards for interdisciplinary collaborative research in medicine and engineering. What can I contribute to the Academy? Well, I think I can work in various domains, but particularly in terms of your our ATSE National Technological Challenge, advancing industry competitiveness, the health technology space, and of course I will promote STEM education. And I will work with the Academy to build relationships between ATSE and the medical community, and now the new Academy of Health and Medical Sciences, and the AMA particularly. As I said, I'm happy to teach leadership skills. I will contribute to ATSE forums on education, health technology, industry and innovation, and contribute to the ATSE group on international collaboration. I have lots of international connections. Now, one thing I would like to say just in conclusion is that I see not only a challenge in STEM education, but also an incredible challenge in bringing technology from the innovation stage, which the universities do very well, and clearly Australia is very good at inventiveness and innovation, but clearly, as you all know, we're not very good at translating that into commercial outcomes. We need to bridge that gap, and that's going to involve this so-called ecosystem working a hell of a lot better than it currently is with government, university sector, and industry. Now, currently, we have government people in the public service and even ministers who seem to have the idea that we don't need the universities. We could have customers going straight to industry to develop their ideas. Nothing could be further from the truth. We do need the university sector to be supported by government, and I don't believe it currently is supported nearly enough, and convincing the politicians to do that is going to be an incredibly major challenge, and the general public to come on board as well. But look at Singapore, look at Israel, look at China. We're going to fall further and further behind unless we bridge the gap. Thank you very much.